The next session is going to talk about low-cost sensors and the need for standardized testing for more reliable and accurate assessments. For this session, we have Ms. Swagata Dey, who's a policy specialist at the Atmospheric Composition Observations Group at the Air Quality Sector at CSTEP. She will be chairing the session. As panelists, we have with us Dr. Mike Giordano, who's the Executive Director at AfriCare, Ms. Emil Verghese, who's a Senior Analyst at the Air Quality Sector at CSTEP, Mr. Adrian Airfire, who's a Meteorology Engineer at Air Parif. He will be joining us virtually for the session. I would welcome Ms. Swagata Dey and all the panelists for the session. I now hand over the mic to Ms. Swagata Dey to start the session.
Good morning and welcome all to ICAS 2024. I've been working on sensors and air quality for a while, and one thing that always bothers me is there are so many sensors in the market, maybe a few manufacturers, a lot of assemblers. So how do you choose which sensor is good for you? Which sensor to choose? Is it the most expensive one? Is it the cheapest one? Do brands really make a difference? Does your location make a difference, and how often do you need to change your network? So to answer these questions, I welcome you all to our panel, which air pollution monitor to choose, and what is it that you need for standardized testing? We don't have standardized testing in India, so what should we do about it? And what is the path for that by ranking of some low-cost sensors? I have an august panel with me. I'd like to first welcome Adrian Airfire. He's a meteorology engineer at Air Parif. He works in the Meteorology and Innovation Service at Air Parif and specializes on projects involving the Internet of Things, embedded and distributed wireless sensor systems, and uses his knowledge of intelligent sensing systems to contribute to Air Parif's digital strategy and the adoption of novel sensing technologies. Since 2019, he has been the project leader for the Recurrent Air Lab Microsensors Challenge, an international voluntary evaluation program that seeks to provide an independent and objective evaluation of performance of microsensors. He received a PhD in Robotics Control and Intelligence System from the Swiss Federal Institute of Technology in Switzerland, EPFL, in 2016, and his thesis was Mobile Sensor Networks for Air Quality Monitoring in Urban Settings. Welcome, Adrian. He's going to be joining us virtually. On stage, I'm pleased to welcome Dr. Mike Giordano. Mike is the Executive Director of AfriCare, the one that Alison talked about earlier in the morning. It's a not-for-profit organization focusing on improving air quality in Africa through the instrument access and capacity building and open data. He has a decade of experience in atmospheric sciences, which has focused both on field campaigns and chamber measurements. And before leading AfriCare, Mike was a research scientist in the US and France, focusing on aerosol chemistry and physics, both in the natural and built environments. He's worked all over the world, including Antarctica and Nepal. Along with that, we have my colleague, Emil Verghese. She's a senior analyst in the Atmospheric Compositions Observations Group at CSTEP. She's completed her bachelor's in civil engineering and master's and MTech in environmental engineering at the IIT, Indian Institute of Technology, Madras. And prior to CSTEP, she worked as a research assistant at IIT Madras. She has a host of academic achievements to her name, but at CSTEP, her primary research interests include ambient air quality monitoring using advanced online and offline measurement techniques, bioaerosol characterization, and environmental data analysis. Welcome all. Couple of house rules. By now, all of you have been introduced to our bell. So our speakers are requested to stick to 15 minutes so that we don't go overboard. We will ring a bell at the end of 12 minutes, right there. We will have one question per speaker after each speaker speaks, and then we will open the floor for questions. And if there are longer questions, we'll try and keep them up in the break. Yeah. So with that, are we ready for Adrian? Okay. So please welcome Adrian Airfire with our first talk of the day.
Hello, everybody. Thank you very much for the opportunity to speak to you. I would like to talk to you today about our efforts in evaluating the low-cost sensors, or like we usually like to call them, microsensors, because the concept of them being low-cost depends really on your budget and what you're trying to achieve with these sensors. And in particular, I would like to talk to you about the latest edition of the challenge, which was the first edition of the challenge to have a deployment in the Global South. Just very briefly, for those of you who are not familiar with Air Paris, we are the accredited association for air quality monitoring in the Parisian region. In France, the mission of monitoring air quality is given to independent associations like Air Paris for each region. Our independence is guaranteed by the fact that we group together stakeholders, all the possible stakeholders. So we include the state, the local collectivities, the representatives from the economy, so potentially the pollutants, and also other NGOs that are interested in the subject. So we have diversified financing, which helps us keep a balanced and independent view on the subject. We also have a transversal approach looking not only at outdoor air, but also indoor air, climate, and energy. The challenge is an Air Lab project. So Air Lab is Air Paris Innovation Accelerator, which is trying to go further and faster in reducing pollution in the region by facilitating and coordinating innovation in the field of air quality and identifying new levers to exchange and experiment. I won't go through all the numbers here for the sake of time, but there have been more than 30 innovation projects since the start of Air Lab, with more than 222 solutions tested, not only sensor systems, also depollution systems within different projects of so let's focus on the challenge. So this challenge was designed to try to link sensors and their use. So to try to make sense of, to help the potential users make sense of what's available on the market, and to provide information on the most relevant sensors by category of use. In this way, establish a snapshot of the technological state of the art at a given time. We also strive to support innovation and to give feedback to manufacturers so that they can improve their sensors. So what the challenge is, it is a periodic evaluation campaign in realistic conditions of commercially available microsensor-based products. What it is not, and it does not try to be, it is not a certification tool. It is governed by the rules, so the terms of conditions of the challenge, which define the way to participate in the challenge, how the sensors are selected, tested, and ranked. Also presents the intellectual property and data property confidentiality, withdrawal conditions, and so on. So this is the main document, and then there's a second document that goes more into the details. This is the challenge protocol. It goes into the technical details of how the evaluation is done by defining categories, the evaluation sites for a given edition of the challenge, the performance criteria, and how we calculate the scores, how we weigh the scores to get a final grade, and how the format of the deliverables. So these documents are available online on the Air Lab website. So I briefly mentioned categories of use. So what we look at is sensors that target different applications, either for outdoor air, indoor air, or what we call citizen air. So these are sensors that are meant to be carried by a user throughout their regular commute or while they work, while they're at home. And within these different fields, we look at applications that target monitoring, awareness raising, in the case of outdoor air, also vehicular applications. For indoor air, we also look at piloting air quality within buildings, so sensors that are meant to work together with action to control different systems of filtering or purifying the air inside buildings. While for citizen air, it's about applications for exposure assessment or again for awareness raising. In terms of evaluation criteria, the number of criteria has varied from one edition to the other, but typically we have more than 20 criteria that are grouped into 5 major classes with weights depending on the category of use. So you might have noticed that we're not looking only at accuracy, but also utility of the sensor for the targeted application, usability. So this has to do more with the experience of use. Either portability or form factor for mobile applications, and also for all applications we look at cost. And just to give you a brief idea of what we do with these different classes of criteria, so how we weigh them. For instance, if we have a sensor that targets outdoor air for monitoring, we will give a bigger weight on accuracy, a slightly lower weight on cost, while for sensors that target awareness raising, it would be the other way around. We would give a smaller weight, relatively smaller weight on accuracy, but a bigger weight on the cost to make sure that these are sensor systems that are appropriate for their use. So, give you an idea how the challenge has evolved. So the 2023 edition was the 4th edition, and we're trying to build now the 5th edition. As you can see, we started in 2018. We quickly had a 2nd edition in 2019, and since then it's been every 2 years that we have a new challenge. The numbers have typically increased from one edition to another, so we have more. Typically, we've had more and more companies and more solutions being tested, and also a more international profile. While the 1st edition had about 2/3 of sensors that were tested that were coming from within France. Since the 2021, the majority of sensors that we test are from outside of France. And we're trying, especially with the last edition, we're trying to reach out to local manufacturers, so local with respect to the deployments that I'll get back to that. You might notice also that in 2023, there was a bit of stagnation, and to give you an idea of why we had this situation, most of the candidates that did not return from 2021 were citing a strain on their supply chains. So they were having difficulties in providing the systems needed for evaluation in time for the evaluation. And this is another view to give you an idea of how the origin of the sensors tested has changed from one edition to another, and how it has diversified. For the last edition, our primary objectives were to push the limit of the challenge format and increase its generalizability of results by adding evaluation environments. And it was the first time that we had an outdoor evaluation site outside of metropolitan France, and this was in Bangkok, in Thailand. We also, it was the first time that we added an environmental and social responsibility dimension. We tried to do a first life cycle assessment exercise. And of course, there was, like we usually have, a secondary objective of further refining the process and also the way we deliver the results. Here, this slide gives you an idea of the way the candidate list evolves during the challenge. So at registration, we had about 34 sensor systems that were targeting outdoor air static applications and 30 in indoor air. Then in vehicular and 4 for citizen air. Already after the first jury, especially the mobile categories were cleaned up because some of the candidate solutions were not appropriate for this type of applications. And by the time of the final list, you can see we had reduced a bit the number of solutions. There were multiple factors in some cases, apart from technical issues with the devices. There were also, even for the candidates that wanted to participate and made a big effort, in some cases, they were also feeling strain on the supply side, and in the end, they couldn't deliver all the sensors that were needed for testing. This slide gives you an overview of the challenge. So this is, again, for the 2023 edition. You can see that typically a challenge starts in the year before the campaign. So it's more than 1 year of work in building the challenge. And once the challenge is launched, we have a period for candidate registration, a quite long period of initial testing of the solutions to make sure that we can operate them and retrieve the data automatically. And then we have the installation period, the evaluation campaign, which is typically 3 to 4 months, a period for results analysis, and then after multiple meetings with the jury, we establish the ranking and we hold a final award ceremony. Like I said, in the last edition, we had a great novelty of having a truly international challenge where we were testing also outside of France. For this, we built a custom monitoring station in Bangkok, which was managed by Airparif with significant support from the Alliance Française in Bangkok and the National Institute of Meteorology in Thailand. You can see on the slide the type of reference material we used. So we were evaluating for particulate matter, both in mass concentration and in number, for NO, NO2, and for ozone. And also the slide gives you an idea of the concentration levels that we had during the campaign period, but also the environmental conditions, so in terms of temperature and relative humidity. So scan this quickly because we will compare them quickly with the conditions that we had in on our French site. So this
Adrian,
we kept the, sorry?
14-minute mark.
Okay,
Thank you.
Thank you. I'll try to speed up. So we kept the deployment site also in France, and you can see that the levels of PM in particular are very different, but also the distribution. So typically in Bangkok we saw more coarse particles than in France. And also in terms of weather conditions, it was very different, particularly for temperature. We also had some innovation for the indoor evaluation. We built up our infrastructure to better host indoor evaluations. And we, of course, kept our mobile evaluations, although the numbers we see typically for mobile applications in terms of submissions are rather small. So the main insights for the previous editions is that the reliability still varies widely between manufacturers and for different pollutants. For outdoor air, PM measurement performance was generally better in environments with higher concentrations and larger particles. So the performance for the same sensors was better in Bangkok than in France. While for gas pollutants, it was more variable, but generally the microsensors faced more difficulties in adapting to different environmental settings. So they had a harder time in Thailand compared to France. This was probably due to limitations in the temperature and humidity compensations algorithms, which were more suited for the European conditions. Well, for the sake of time, I'll skip some of the information on this slide. But yeah, in terms of cost, there weren't big changes compared to previous editions, and you can see that the range of price of a sensor can vary a lot, from hundreds of euros to thousands. And finally, yeah, we have a results platform that's interactive, that allows you to filter and rank results, to visualize the reports with different degrees of details, and to have side-by-side comparisons. I encourage you to go to this link and play around with it and try to see if you can find an appropriate sensor for your application. Thank you. I look forward to questions and to productive discussion.
Thank you, Adrian. We'll keep the questions to the end in the interest of time. Mike, would you like to go next?
Sorry, while we're waiting for this, during this, if I pause for a second, I apologize. I just landed a few hours ago, so I'm just waiting for the coffee to kick back in. Okay, so this talk is really going to be a kind of an open-ended kind of discussion, right? The title of the whole session is like, where do we stand on ranking and evaluating sensors, and how do we get to these kind of standardized, standardized protocols for doing that? And I'm going to talk a little bit about AFROSET's specific experience, but keeping in mind that the specific experience of AFROSET is built into part of the design of AFROSET. And so while I think that there's a lot that's transferable between what AFROSET does and especially what Indicet will do and what is applicable to a lot of the other parts of the world, it may not be applicable everywhere, right? So we're going to have to kind of think about this and have a discussion about this. Sorry, I'll go ahead and start a timer for myself just so I know where I'm at. Okay, so as Allison talked about last session, right? AFROSET, the Sensor Evaluation and Training Center for West Africa, partnered with a bunch of people all over the world, ICAS+CAMS-Net, Air Paris, who Adrian just talked, NILU, and India. So I'm not going to talk to anything about what we're doing, but I do want to kind of answer this one question about why is it in Accra, in Ghana? So it turns out, right, Ghana, like a lot of the tropical world, all the tropical world, has a rainy and a dry season, right? And in West Africa, this is controlled by the Intertropical Convergence Zone, the ICCZ, basically moving north and south, right? North and south. And what happens is that in the dry season, right, you can get these events called the Harmattan winds, which are basically extremely dust-laden winds from the Sahara Desert that blow out over the Gulf of Guinea and can result in insanely high PM loadings, right? And so this is just PM 2.5. This is what we measured this past year. You can see, right, we're touching 200, 250 microgram per meter cubed of PM 2.5. And of course, the PM10 is even higher than that. You know, and this is leading to severe health issues, right? So this is kind of why we're doing this in Ghana, is because this provides some unique opportunity to really look at how these low-cost sensors are going to perform in this kind of you know, high and low concentration environments. So, right, in this idea of ranking and evaluating, and which, just for the record, AFRSET does not rank sensors, but we do evaluate sensors. There's a slight difference we can talk about and like what that means for your stakeholders and your audience, and that's kind of at the end. But really this question here, and you know, Faye talked about this co-location idea, and we're gonna go a little bit further into it and say, you know, how do you actually disambiguate performance of a sensor, right? If you co-locate your sensor and you're only looking at data in the rainy season, is that going to give you an accurate picture of performance and a ranking during the dry season? And you know, really the answer here is a strict no. It just won't, right? You're looking at data that's 20 to 30 microgram per meter cubed for a part of the year, and then you know, it's touching 100, 150, 200, 250 micrograms, right? It's just not going to be the same kind of performance. And you can see this, right? So here on your left side, at the top, right? This is just sensor, one type of sensor, from one manufacturer, 3 different units, evaluated against the reference monitor that we have at AFRSET, right? And so you have the rainy season and the dry season on the bottom, right? And so you can see there is a very big difference about just how linear this kind of data is, right? So again, think about this idea, and you're trying to rank one sensor versus the other, but one of your sensors is evaluated in the rainy season, and then the next one's evaluated in the dry season, right? That's not an apples to apples comparison, right? This is not something that you can just pluck and choose and say, okay, here's this time we're going to look at it, and then try and do the same to another one. And then on the right here, on the same, these graphs, you have the rainy season on top, dry period on the bottom. Just looking at the mean absolute error versus the R-squared, right? So the linearity and the accuracy. For a couple different sensors, we won't go into different performance about this, but just to, you know, if you look at just the purple circle, right? Or the light pink circle, and look at its performance just in terms of, you know, like R-squared. You know, at the rainy season, you're about like 0.52 or something like that, and in dry season, you're closer to like 0.7, right? So, but MAE, much different. So again, really need to be very thoughtful about when we are taking data to be used for evaluations and comparisons between sensors. And there's something to be said for the way that Air Paris does their microsensors challenge, right? Which is during a set. And so there's this real big question about how do you tailor these kind of rankings and evaluations to your audience? And I think that's an open question. I don't really have a good answer for it. But hopefully, in the next couple of slides, we'll kind of talk about this. Excuse me. So, I really want to hammer this home, right? You must do an evaluation or ranking or however you want to term this, and whatever your actual end goal is, right? It must reflect the actual use that you expect, right? This is the whole reason we push for co-location of sensors, because they should be co-located with a reference monitor where they are going to be used, right? But it goes beyond that. And specifically, I think we need to be asking, is the type of testing that we're doing at AFRSET, and I think potentially at INDICET, is that going to be necessary everywhere and all the time, right? So we really do need to be focusing on, like, who's the audience, and what are they looking for, right? What are the potential use cases for their sensors that they're going to be doing? If you have someone who comes to you and just says, oh, we want to look at a very targeted, small evaluation campaign for, I don't know, roadside monitoring, right, for just a couple of months of the year, then do you need like this full dual season evaluation? Do you care about the performance in one season versus the other? Probably not, right? But if your audience wants something that's applicable to continuous ambient monitoring, then you do need that kind of data, right? You do need this kind of setup for what we're doing at AFRSET. And then there's a good question here about faking it, right? Using chambers and flow tubes and like supplementing ambient data with lab data. Going to leave that one as an open discussion, just because there's a lot more work that goes into that than I'm implying here. And then also this whole idea of now you do have 2 different seasons, potentially multiple more different seasons, depending on where you are. How do you weight that, right? How do you weight differing performance in different conditions? Do you ever present just overall performance and like take a whole year? Do you time average, time weight that? Or do you just always keep them separate, right? You say, okay, this is dry season performance, this is rainy season performance, here it is. Your audience, your stakeholders need to be making decisions based on that. And so I'm really super cognizant of time, so I'm not going to be going too far into detail. But these are the metrics used by AFRSET, right? So the first part of that was all actual evaluation design. And this is going to be kind of how do you actually get to performance or a ranking from that work that you just did, right? So this is what AFRSET uses, right? We use some like linearity instrument agreement. We do some bias, variabilities, precisions, right? Like, great. I do just want to point out a couple of things here. Again, being super cognizant of time. At AFRSET, we do things in triplicate, right? I think this is kind of the standard SOP. We take one manufacturer, we get 3 different units. And there's a lot of important reasons for this, right? I don't know if there's a reason why 3 is the magic number that we've all chosen, but that's what it is, right? So because of that, right, we do need to be keeping in mind individual unit variability, right? Intra-unit variability. Are manufacturers providing units that are relatively in agreement between each other? And how do we actually measure that, right? And then, how do we actually take intra-unit variability data and report that out, right? Like, is that something that needs to be public-facing? Is that something that needs to be, just internal that we use when we're actually doing these comparisons? Again, I'm not going to give any real thought on this. This is open for discussion. Bias, right? You take basic science courses, you learn that when you are doing data collection, you have accuracy and precision, right? We do need to be measuring both of these things. Bias is sort of helpful for this. there's a little bit of discussion on, what actual metric you use for this and how it should be reported. But I'm, again, in the interest of time. And then I will spend just a hair of time on this as well. I am guilty of this, right? Like I have a review paper that's a lot of people in this room are co-authors on, that basically says we should be using R squared as some sort of evaluation metric. When in reality, this is probably not actually a good way to go about this, right? R correlation coefficient, R squared coefficient of determination, we all kind of know what these are. We all have some sort of exposure to this just from basic science courses. The problem is that this is not actually an appropriate variable, probably. Okay, there's my bell. Really what we should be using are like bland Altman plots. This has some cons, right? Because these are graphical, which is great, but they're not a singular number, which makes it harder to compare, and yeah, okay. Final notes. Standardized testing methods, we do need this. We do need to, like, as a community, come up with something. In AFRSET, right, we are showing the importance of doing this on like a regional scale, right? So as Allison mentioned, AFRSET South, AFRSET East, we hope are going to be, realistic and set up soon. You guys have INDICET that's coming, maybe plural. Maybe you find that you need more geographic locations to do this completely in, right? And then we can get into ideas of like Southeast Asia and Latin America and all these kind of fun stuffs. Okay, cool, thanks.
Please request you to introduce yourself, and then we can take the question.
My name is Vikas Kumar. I'm a PhD student in IIT Bombay. My question is basically, as you also talked about it, that a lot of them, the low-cost sensors that we see in market are just assemblers. So have you found out, like, is there any difference between if you take whose base sensor is basically, for example, plant tower, they are using the same, but why is the results very different from each other if different manufacturers are providing that?
Yeah, I would direct you to our website, which has all of our evaluation reports. The short answer is yes. There's a couple reasons for that, right? There are different geometries and setups that manufacturers use. They take a plant tower, right, and they put it in one housing versus another. That can have real effects on how these things perform. But another thing is, what do manufacturers do with the output data of that little plant tower sensor, right? What level of transparency do you have in that data? Are you given that base level output, or are you given something that's, X number of levels of calibrations pre-applied, machine learning pre-applied, right? At AFRSET, we are aware of manufacturers who want to use their performance on, their calibration performance as like a major selling point, right? And so what we do is we say, okay, let's get both the raw data and your calibrated data, and let's be transparent about it, and that way all of our potential users and stakeholders have an idea of what your performance should be, right? That's basically how we do it.
We'll keep the remaining questions for after Emel's talk. So thank you, Mike. Big round of applause. And thank you for sticking to time. Emil.
Yeah, so hi all. So today I'll be presenting on the performance evaluation of 48 multi-pollutant low-cost sensors, which was done in INDICET, Bangalore. Yeah. So this evaluation was part of a project wherein we are looking into evaluating the long-term performance of multi-pollutant low-cost sensors from different Indian manufacturers by collocating with the reference instruments. Also, we are deploying 45 multi-pollutant low-cost sensors across Bangalore to identify the hotspots as well as to develop the spatial maps of various air pollutants to estimate pollution exposure. On the right side, you would see the land use land cover map, wherein we have right now deployed all the sensors, especially we are targeting the Bangalore, the built-up area in the Bangalore urban region. So Subbu has introduced about our India Sensor Evaluation and Training Center. So here we have the air quality monitoring station, which is which has reference grade instruments for PM 2.5, PM 10, and gases NO2, ozone, CO, and SO2. We also have the weather station for the weather monitoring. For the PM 2.5 and PM 10, we are using the beta attenuation monitors, and for the gases, we have the real-time gas analyzers. So our testbed is capable of housing up to 60 sensor nodes. Coming on to the evaluation methodology. So firstly, what we did in this project was we made sure that these the manufacturers are commercially available in the Indian market, and also we made sure we had at least minimum 3 nodes from each of the manufacturer or the so-called integrators, I would say. And they were able to, the check we did was they were able to measure the various pollutants and reports the data in the near real time. Coming on to the collocation part, the sensors were installed at the testbed in Interset for collocation with our reference monitors for nearly 4 to 6 weeks, wherein firstly we made sure that we eliminated the points for the warming up period. That is, when you look into the gas analyzers which are having electrochemical sensors, so nearly we eliminated nearly 1 day data period, because that would be the warming up period for these sensors. And then we looked into the data availability. So that is, what is the number of data points that would be coming per day. And when we are doing with 6 different Indian manufacturers, so the first thing what we did was to harmonize the data from the manufacturers. That is, to standardize the data names, to standardize the units, how they are expressing these pollutants, whether it is the concentration or the or it is the mixing ratios that they were reporting. So these were standardized. And then we started the performance evaluation. So firstly, we assessed the precision of this device. Say you have 3 devices from the manufacturer. So what is the precision among these devices was the first check that we did. Then secondly, we know that the sensors have raw values, as well as they have the manufacturer reported or the factory calibrated values. So we made sure that we checked the accuracy with this with the reference instruments. Then, and we were following the initiatives set up by AQ+CAMS-Net, AFRISET, as well as the US EPA guidelines for our assessment. And finally, we try to see to develop a localized calibration model and see the performance of how can a localized calibration model perform when compared with the manufacturer reported values. Now, coming on to the sensors we were studying. So we had, as it was part of the long project, we had 25 sensors from Orasure, then 5 sensor nodes from Sensitram, Aeron, Airveda, and Respirer, and 3 of the sensor nodes from Airvoice. For PM10, we considered AlphaSense OPCs that was integrated in Sensitram, Aeron, and Respirer. Then for PM 2.5, we had Aeron with Terra sensor, then Airveda, Respirer, Sensitram, and Airvoice installed with a plant tower, Orasure installed with a Sensorion. For the gas analyzers, we used we were having 2 types of electrochemical sensors. The Orasure was installed with the EC-Sense electrochemical sensor, and for the remaining 23 of the sensors, we had the AlphaSense electrochemical sensors. So here I'll be talking about the results from our evaluation. So we followed the USAPA. Firstly, as I mentioned, we checked that what is the precision among the devices. So I'll be right now in this presentation, I'll be talking about how the accuracy is with the manufacturer reported values. So firstly, for the manufacturer report PM 2.5, the US EPA has recommended that the target of R square greater than or equal to 0.7. And we, from our analysis, this is for the manufacturer reported plant tower, Terra, and Sensoron sensors, where we have seen that 2 of the sensors from SensiTram were able to pass the target, while the rest of the sensors, majority of the sensors, I would say, were able to achieve at least achieve a 0.5 R-square. And when we look into the different type of sensors that I said for the OPCs, so we classify it as OPC and non-OPC sensors. So for the alpha sense OPC sensors for PM 2.5 and PM 10, all the 3, like we had it for Aeron, Respirer, and RAM, SensiTram. So all of these devices couldn't achieve the R-square greater than or equal to 0.7. Now coming on to the NO2, what we so in the first slide you could see the manufacturer reported NO2, as well as I mentioned that we did a localized calibration. So we noticed that when you look the manufacturer reported values throughout all the sensors, whether it is Orasure, I mean whether it is Airweather, whichever brand it is, or whichever the sensor it is, that is the Alpha Sense or the EC Sense, we have noticed that the R-square grid is the R-square is not able to achieve the target, while when used with the localized collocation, there is an improvement in the linearity for the NO2. And similar is the observation that we saw for ozone also. And for ozone, the USAPA recommendation is R-square greater than or equal to 0.8. And similarly, we were seeing that with the localized corrections, there is an improvement in the linearity in the gas for the ozone sensors. Yeah. Now in this plot, so what we are comparing is the CVMAE with the Pearson R. So when you look into the figures, what we are trying to say with decreasing error, it is a better one, as well as the increasing Pearson R. So if you see in this plot as well as in the coming next 2 slides, you'll say that if the data points are more towards the left corner, it will be better performance compared to the others. So we compared the manufacturer reported data for the non-OPC sensors, I would say, that is the Terra, Plant Tower, and Sensoron, and the OPC sensors. And on the right side, you will have the how the localized calibration is performing. So here, when you look into the performance of the manufacturer reported as well as the locally calibrated, the main improvement is that with the local corrections, we were able to achieve a uniform performance of the sensors, irrespective of whichever brand that is. Now coming on to a concept like when we are reporting PM10, we try to see reported the PM10s from a hybrid, like we developed a hybrid model as well as a particular just an OPC model. So hybrid model concept is that we are using either the one with Plant Tower or Terra or whichever it is with an OPC and seeing it. So that is, if you're calculating PM10, what we see is that we'll be reporting for the PM 2.5 with the non-OPC ones, and the coarser fraction, that is PM10 minus PM 2.5, we are considering it as from the OPCs. So in this in our calibration, what we were able to see that we were able to we were able to get an error approximately 20% and an R value which is approximately 0.7. Now coming on to the performance of the gas analyzers. So for NO2 and ozone, first let me move on to NO2. So you could see that for the manufacturer reported values of NO2, the error is really high, while when you look into the localized calibration, the errors has really decreased. As well as we could see that the Pearson correlation is really improved with the localized calibration. So this is, and when you look into the ozone, so we have these, when you look into ozone, we have seen that the way, within the devices itself, there is a huge standard deviation that we are noticing in it. And also, once when you look with the localized calibration, the error has really decreased approximately 10% with a Pearson correlation which is greater than 0.9. Yeah. So coming on to the summary. So with this, with what we understood from these evaluations is that with a localized calibration, the sensor performance has really improved, especially when you look into NO2 and ozone. And one of the greatest challenge that we faced when we were evaluating sensors from different manufacturers is how the sensors are how the data is being reported. Like firstly, what is the data format each of the manufacturers use? Then how the sensor, the measurements, like whether it is 1 minute averaged that is being reported or whether it is the 30-second averages. So that was a challenge that we have to harmonize the data. Also the unit parameter names that is given. If you would be giving it a different name, if you would give it another name. So that was a challenge. And finally it was the mixing, what is the representation, whether you represent it as the mixing ratios or do you represent it as the concentrations. And also these results, I would say that these results are based on short-term evaluation, and there is currently we are actually continuing our long-term performance evaluation of the sensors as well as the different models that we have built. And for how we have built these models, actually it will be, you will have a session in the afternoon wherein we will be talking about the advanced data analytics for hyperlocal air quality air pollution action, wherein Dr. Neerav Lakinwala will be talking about how we develop these localized calibration models. And also we have a poster put up by Dr. Nidhi Malik on the seasonal performance of the calibration models. So like if you would like to discuss with me, I'm open to discussions. And also after like if you need any assistance in how we do this sensor evaluations, please feel free to contact me. Yeah, thank you.
Do we have a question for Emil? And then we'll open it up. All right, Soumya. I can see you waving. Quickly, Adrian's still with us online? Great, perfect. Yes, Soumya, do we have a mic?
Thank you so much, Nidhi. Sorry, Emil. Great presentation and very informative. I have just a very quick question. Maybe I missed from your presentation. What is the manufacturer reported, these values? How do you get that?
Yeah, so manufacturer reported values are the ones which you get in the dashboard, right? The exact value. So for sensors, what is the factory calibrated values?
So those are basically given by manufacturers only?
Yes, yes. So they'll be either conducting a collocation from their side before giving us the sensors, or it might be some factory calibration that they have done for the sensors.
So interestingly, they manufacturer themselves, they give lower, for me it's very interesting to see that the values given by them or factory calibrations are lower than the one we are doing. That's what I understood from.
So mainly this like when I say the factory calibration, so maybe these sensors are calibrated in different geographical conditions.
Yeah.
So and we have collected it from 6 different manufacturers who are spread across India.
Right.
So therefore they have their own geographical limitations. That is not like when we compare it with our reference monitor, due to geography, that is the temperature and RH itself, the sensors might be performing differently.
Okay.
Also, they might have done some calibration models would have been prepared. So due to which there will be a difference that maybe the models have not seen what is the concentration in the current geography. It can be this reason that it is performing lower.
Yeah, thank you. So it's a lesson learned for the manufacturers that they should also, do the calibration in different settings, right? Thank you.
Thank you. That was Soumya Singh from IFM Bhopal, and we'll open the floor to questions. Emil, you can come back. Then you ask your question, just introduce yourself and tell us, Emil, please. Just please specify who the question is for. Ronak.
So hi, my name is Ronak Sutaria from Respirer. I had 2 questions, probably for all 3 of the speakers. One is, in all your evaluations, even at AirPerif or Africa, what Mike did and then what ML has done, is there merit in having, most of the publications do high and low results, at high concentrations and low concentrations. India goes up to about 800, 900 micrograms. Do we need more bands in which you evaluate? Because 50 and 100 is not high and low enough. We need results at 500, 800 micrograms. A corollary to this question is there merit in having artificial particle sizes in the ambient space used during evaluations, both for different particle sizes and particle densities, so that, because all of you are doing it at one location, and you are probably getting consistent particle compositions and particle densities. When we deploy nationwide, the particle densities vary significantly. There are artificial particle generators, but I would like to know views of having a wide variety of concentrations and densities in a single location. And is there any thoughts on, can that be done, or, yeah?
Mike, would you like to go at it? Yeah.
Yeah, so I kind of touched on this a little bit with the idea of like faking it, right? Just to extend the data range. My background, my PhD was in chamber work, and there is a lot of work that goes into doing good chamber work and making sure that your results are actually usable and realistic. And in a lot of places, the capacity to do that is not quite there, right? Which is why I generally stay away from it, and I would still recommend that doing ambient conditions where you get that 500, 800 microgram per meter cubed is probably the way forward. I don't know if Adrian has any ideas, because I know you guys do some chamber work.
Adrian, yeah, please go ahead.
Yeah. Thank you, Ronak, for this question, and thank you, Mike, for your first thoughts. Well, we do chamber tests, but not within the challenge. Apart from, like Mike said, the difficulty of doing this properly when you do it, scope of the challenge, this would actually be impossible, because we're testing, the main idea of the challenge is to test multiple platforms at the same time, and having tens of different sensors tested at the same time within a chamber would be impossible, because we don't have that kind of chamber. But there is merit to doing this type of testing. I would say, I'm always looking at it from the perspective of potential users. I would say that you always want to do some tests that are in the environment that the sensors will be used in, as extensive as possible, but you'll always have limitations of time. And so maybe you won't cover all the conditions that you might have in your actual application. So it would be good to test multiple platforms in real conditions, so that you get a short list, and perhaps after that you can try to do some more in-depth tests on the best sensor systems that you eliminated in the first stage. There is definitely merit in doing lab work, especially if you have projects that are really looking at having a high accuracy of your data, but then there's a lot of work in doing good chamber exposure evaluations. And having, apart from doing the evaluation properly and having the right chamber, if you're looking at particles, having the infrastructure to generate particles, different sizes, different densities, it's a lot of work, and it's a lot of investment, even financial.
Thank you.
So,
Any other questions?
Yes, I have a question here.
Oh, yes,
Yeah.
Victoria, please.
To Mike.
Could you just introduce yourself to the audience?
Okay, so I'm
And then
Victoria.
Namita can go next.
Victoria Owusu-Teria, a PhD student from Ghana. With regards to air quality data analysis, I wanted to ask if you could advise on correlation and then coefficient of determination. Which one would you suggest we use over the other? And is it good or advisable to use both to check the performance at the same time?
All right, there's a
Thank you.
PhD student and here's an advisor. This is interesting. Yes, Mike.
Okay. Full disclosure, right? I did write a paper that said just report both of them because it's easy to do so and it's useful regardless. I don't know how much I want to open up this can of worms in this discussion of whether or not R or R squared are even applicable. When you're comparing two independent measurements, right, the short answer is they're really, from a statistics standpoint, they're not, right? And like Bland-Altman plots are. But that being said, having a value that you can look at, especially if you're going to go to a policy or decision maker, having a single value is valuable, right? There's no way around it. Having something that you can say, okay, 1 is the best number that we can have here, then taking that and then comparing it, it's like, oh, here, you can look at this graph and it says, oh, some percent of the time it's within spec, but what's spec for you? This is also like a arbitrary decision, and yeah. Report it all. I think that's my short answer, is just do everything, right? It's a small amount of work, and the audience that you are talking to or is using your work can use whatever they think is most applicable for them.
Before I take the question from Namita, if there's any questions online, I would request you to put it on chat, and then it'll come to me, but I don't see any at the moment. Yes, ma'am.
All right, my name is Namita. Thank you so much. This was an excellent session. I am the founder of Ayurveda, which is one of the monitors which Emil talked about. So actually, one of the questions, that we struggle with is, as Emil mentioned, right, that the calibration and the performance of sensors depends a lot.
So we're basing ourselves on the academic state of the art, and then there are similarities between what we are doing and what AFRISET is doing, and I guess also what ICAS+ is doing. I haven't had a chance to look at a protocol, so there are compatibilities. Then you'll see that there are similarities if you check our different protocols. We're targeting pretty much the same concepts. Maybe the metric is a bit different. And in terms of the way we're doing it, again, there are similarities between what AFRISET is doing, so trying to get different environmental conditions within the campaign period. They put a big focus on that, and it's really inspired also us to better on this aspect. But I wouldn't say there's no really overarching standardized way of doing it.
So I'll take one online question and the lady at the back then. So we have a question from Raju NV, which I do find pertinent. What's your views? I know it's still a few more years to go, but is there a possibility of calibrating sensors using satellite data now or later? Should we work towards it? Mike?
Yes, no, maybe. It depends on your satellite data and the data sources that you're using. A lot of the satellite data that is relevant is single pass, meaning it's one snapshot of one time during the day over a place at pretty, low spatial resolution, meaning the grid sizes are very large. There are some options that maybe you can get to work and could probably work pretty well, but open research area, I guess. Something to look forward to.
Thank you. One last question at the end, and we'll take the other questions later in the interest of time.
Hello everyone, good morning, I'm Suchi and I've recently finished my PhD from Indian Institute of Science. My question is in continuation with Ronak Sutaria and Namita's comments. Is there a possibility to look into interactions also with recording time? Because you said that accuracy will also depend on multiple factors like density, spatial distribution, and time, which is majorly the same for many commercially available sensors. So do you think there's some possibility wherein we could optimize the combination of these multiple variables and recommend in a zone with a range of densities, temperatures, humidity? Because for instance, if we have a housing of, say, plastic, and we expose it to a microenvironment with less trees and complete sun, the values you see there will be very different from the values that you typically see in a shaded environment. So do you see merit in, again, coming up with a coefficient correction or some logistic that accounts for that? And is there anything available of that sort?
I'll answer part of that. Tomorrow afternoon, we have a session on South Asia Community of Practice. And one of the questions for that discussion is, how do we harmonize even within the manufacturer ecosystem and bring in some sort of standards, especially when we don't have government standards yet. But rest of it, I will defer to our experts.
Adrian, do you have any thoughts on that?
Well, it's I would say it's different to be able to give an answer for all conditions. And what we're trying to do is the challenge is what we've tried already in the previous edition is to multiply the sites, so have multiple exposure sites, and by publishing the conditions of the sites, provide more information to potential users. I don't see how it could be exhaustive on that and cover all the potential conditions and apart from trying to, like I said, multiply the sites and coming up with some metrics to be able to, for a potential user that's in a particular region, say with some degree of uncertainty, your conditions are similar to more similar to this site that we've tested within this edition of the challenge, and you should be looking at this list of sensors. But in terms of having coefficients to adapt to this, the challenge doesn't do that. We work with the calibration of the that's provided by the manufacturer. So this is something that I know that ICAS is doing differently. It's interesting for us, but I don't see how within the challenge we could provide this for the different the big numbers that we're having in each edition of different sensors. I don't know if I answered that completely.
Yeah, I think that the range that you would have to cover would be very large, right? Which is why I was talking about, like, and Allison was pointing out, like, we're going to need an AFRISET east, west, south, probably even north, right? Just to cover that range. A lot of that's unknown, right? We don't even know the whole range. And I don't even know if the whole range is known even within India, right? So I think the short answer is it's probably just easier to replicate things in different areas than it is to do like a sort of standardized thing, because again, that requires a lot of internal capacity within your evaluations, even for manufacturers, to be able to do and do well and do correctly. So,
Thank you. So that was way too much than I had anticipated, and I'm glad, we're discussing this. But this is a wrap from us for this session. I'll hand it back to Anshika. I would thank my panelists. Adrian, hopefully next year you can get here. Thank you, Mike, and thank you, Emil. And thank you all